Hi, I'm Maren Vernon. I am a web developer and a coding educator. And today we are going to learn how to talk to a computer by writing code. At the end of this lesson, you'll be able to write a simple computer program to move a character around on the screen. So let's go. We are going to use a program called Scratch. Now, Scratch is great because it was developed by the people at MIT to help kids 8 and up learn about code. When I start Google Chrome, Safari, Firefox, any web browser that I choose, if I type scratch.mit.edu into the browser URL bar and hit enter, it'll take us to the Scratch website. Now, there are multiple ways to use the Scratch website. One is to create an account, which is free, and that will enable you to create different programs and save them to your account. Another way to use Scratch is simply to hit the Create button and begin exploring right away. The downfall of not logging in is that any work that you create will not be saved, although we can talk about a slight workaround in a moment. The third way to use Scratch is to actually download an offline editor. If I go to scratch.mit.edu/download, I'm able to download the Scratch application based on the particular operating system that I'm using. This means that I don't have to be connected to the internet in order to use Scratch. Anything that I create won't be saved to my online account unless I log in online and upload it later. So if you don't want to create an account, downloading the Scratch application is a great way to go. One thing to note, if you're using your school Chromebook, you probably will not be able to download this application and save files to the Chromebook. So if you want to have that ability, you'll probably need to do this on an alternate laptop. When I go to the main Scratch website, you'll see a couple of things. You'll see some featured projects and featured studios. You'll see some projects and studios curated by Scratch members, and some talk about what the community is loving and remixing. We'll talk a lot more about projects and studios and remixing later, but this is a great place to kind of see what can be created with Scratch. The other thing you'll see at the very top is options to create, explore, ideas, and about. I'm going to hit the Create button. When you first log into Scratch and you are brand new, one of the things it will offer you is some tutorials. These will pop up right away on the screen. You can always close out of them if you don't want them. But when you log back in later, if you'd like to access the tutorials again, you can always hit this button up here that says Tutorials. Before we dig into coding in Scratch, let's talk for a second about what computers do. They really do 4 things: receive input, they store information, they process information, and then they output something. An example of an input could be typing a command on a keyboard, clicking somewhere on the screen with your mouse, talking to the computer with a microphone, like I'm doing now, or moving, like raising your hands up and down, so a motion sensing device can tell the computer you are moving and how. The first thing the computer needs to know is what input to expect. It needs to know when to start running the program that you're creating. Then, when the computer knows what input to expect, it needs to store and process some information. For example, let's say that I've written a script that calls for me to input 2 numbers in the keyboard. I might input 2 and 2. If I tell the computer to store that information and then process it by adding those 2 numbers together, my output would be 4. The key when you're talking to the computer is to make sure you're talking in a language that it understands. The language it understands is called a programming language. Now, there are lots of different programming languages, just like there's lots of different languages around the world. For instance, PHP, JavaScript, Python, Ruby, and Perl, just to name a few. But today we're going to practice with the Scratch programming language. What we're seeing on this Scratch screen is a brand new blank project. Each new Scratch project starts with the Scratch cat on a white backdrop. The part of the screen that the cat is on here is called the stage. This is called the stage because you can think of it like an actor performing on a stage. They will perform their lines and their moves as directed. And here, the characters, in Scratch known as sprites, will perform your actions and follow your directions, perform any lines you've written over here on the stage. We can always change the characters, the sprites that we're using, and the backdrop here. There's another section here that is the script area. This is where you will write your code algorithms. You will write those using code blocks. You'll see the block palette here on the left side. You can use your scroll wheel to scroll up and down, or you can use this handy little quick guide to jump to certain categories of code blocks. There's a few other features here, including some tabs that talk about costumes and sounds. There's also an area down below the stage that gives you some information about each sprite that you're creating. And then if you are logged in, up top, you will see your username and you will see options to periodically save your program. If you don't log in, you'll always find those here under the File menu. You'll find the option to save the program to your computer. We can adjust the sprite and the backdrop. This little cat face icon, when you hover over it, gives you some options. You can choose a sprite that has already been drawn and created for you. You can paint your own sprite. You can get a sprite that Scratch chooses for you, or you can upload a picture. Just make sure that any pictures you upload are appropriate, because Scratch is for students 8 and up. On the backdrop menu, you'll have the same options. Choose one that's drawn for you, create your own, get a surprise, or upload. Let's click on this Choose a Backdrop. You can either click here, the little magnifying glass, or here to get to the backdrop menu. You can scroll through to see all the backdrops that are there, or you can use this handy little menu up top to be able to get to specific types of backdrops. For the moment, I'm going to grab a backdrop that's a grid. So I can type in the search box grid, and you'll see 3 options show up. I'm going to choose the 30 pixel grid. I can also choose my characters. If I don't want this Scratch cat, I can click on the little cat face. And when the menu comes up, you'll notice as I hover over certain sprites, some of them actually move, and some do not. The movement piece is showing you that this particular sprite has multiple costumes or multiple drawings associated with it. That could be good to know because I might want to animate my particular sprite later and make use of all these different costumes that have already been drawn for me. Or there might be different colors of the costume already created for me. I'm going to go with the Scratch cat, but if I wanted to go with a different one, I could always click on it to select it, and you'll notice that it's added to my sprite menu. If I chose one in error, I can always select it by making sure it's got the blue highlight around it, and click the little garbage can X to remove. Let's write a very basic script and see how we use these code blocks to create a set of commands or an algorithm that makes my sprite do something on the stage. The first thing that I'm going to do is tell my computer when to run my program, because as I said, computers are looking for input. Most Scratch programs are started by clicking the green flag up top above the stage. So I need to find an input that talks about when I click the green flag. If I look at my blocks palette and I go to the events blocks, you'll notice there's a block here that says when the green flag is clicked. In order to add that to my scripts area, I simply click on it, drag it, and drop it. If this area is too small, you can always use the zoom in and zoom out functions in order to make this bigger. You can also click and drag to recenter it any way you want on your screen. Now that I've told the computer when to start running my program, I need to tell it what to do. One thing you'll notice is that this block is sort of shaped like a baseball cap. It's a hat block. Hat blocks are set up this way to tell us that it is an input block and nothing comes before it. It's designed to start a script. You'll notice that there's a bump underneath this hat block. This bump tells us that another block can connect to it. If I go to my blue motion blocks, you'll see I have a block here that talks about moving. If I drag that here to my script area, you'll notice that there's a bump and a notch that would fit together. If I hold one block close to the other, you'll see this gray shadow appear. That tells me when I let go, they'll connect, like Legos. In order to separate them, I simply click it and drag it away. This block is called the stack block, and you'll see that there's a notch on the top and a bump on the bottom, so another block could connect to it as well. So we snap these blocks together to make a script, and then we click on the green flag to run our program. When I click the green flag, as you watch the stage, you'll notice a tiny bit of movement by the cat. Not a significant amount, but a bit. That's because these steps that the character is taking are pixels, so they're very small. If I want to increase the amount of steps that my cat takes, I can click inside the move block and adjust the number. Maybe I want to make it bigger, like 60. Now when I click my green flag, you'll notice he moves a lot farther. One thing about having a character move around on the stage is it really depends on the direction that the sprite is facing in order to have it move the correct way. What do I mean by that? Well, the computer doesn't understand commands like face up, face down, face left. It understands direction by the number of degrees. If we take a look at this cat, you'll notice that he is facing toward the right of the screen. And if we look down below in the sprite information area, you'll notice a bubble that talks about direction. And it says that our cat is facing direction 90 degrees. When I click in that bubble, you'll see this handy little object pop up. And if I grab that little arrow and I change the way it's pointing, you'll notice that my character's direction changes as well. At the very top, we're at 0 degrees. At the very bottom, we're at 180 degrees. Facing to the right, we're at 90 degrees. And facing to the left, we're at negative 90 degrees. It also means that we're upside down. Whichever direction your character is facing is the direction they will move. So you'll notice here, if my character is facing negative 90 degrees, when I click the green flag, it will now move to the left. If I change the direction to 90 degrees, it will move to the right. Same with facing up at 0 degrees or facing down. Now, I can alter the direction of my character here in the sprite area, but in order for the person running my program to be able to make sure that the cat is starting facing the correct direction, I actually need to put that into my algorithm, into my script. You'll notice that there is a blue block here under motion talking about direction. Point in direction. I can use this block in order to make sure that my character starts out pointing in the correct direction. In this case, perhaps I want my character to start out facing the right and moving right. So I want it to point direction 90 degrees. You'll notice when I click on the number, it gives me that same option here. So I could type in a number, or I can use the arrow to input the number. I am going to add this block here underneath and click the green flag. That seemed odd. The character first moved and then changed direction. One thing that I have to keep in mind as I'm writing my scripts is the order in which my steps are run. The computer was just following my exact directions. When I click the green flag, move, and then point in direction. If I want to ensure that my character is first pointing and then moving, I'm going to need to change the order. When I remove this block from the bottom, you'll notice if I hover between these two blocks, they open up and allow me to drop this step right in between. So now my instructions say, be sure to be pointing 90 degrees and then move 60 steps. I'll change the direction of my character to ensure that that worked. Right now he's facing 0 degrees. When I click the green flag, it seemed to have worked, but it went so fast I really couldn't tell what was happening. So one other thing I can do to slow my code down so that my eyes have time to catch up is to click on the control blocks and find a block that talks about waiting. This wait block is really handy. I can input it into my code and slow everything down so that my eyes can really see what's happening. I'll put it here at the start of my code and in between my two steps. Now I'm going to change the direction of my sprite, click the green flag. It worked. By slowing it down, I could tell that my code first changed the direction of the sprite to be facing the correct direction, and then told my sprite to move 60 steps. And if I wanted my character to dance around, I can do so by grabbing more blocks here from my blocks menu. Or if I'm repurposing a piece of code that I've already written, a handy trick is to right-click with your mouse to bring up an option to duplicate. Whichever block you click on is what is duplicated. Whatever falls below that block is duplicated. So if I right-click on my first step and say duplicate, you'll notice I've got a copy, and I can place it wherever I like. I can adjust my code. First, maybe point in direction 90 degrees and move 60, and then maybe point 0 degrees and move 60. Then maybe do the whole thing again. Maybe this time point -90, and then point 180. Let's see what this does. If my cat is starting to get too far off my screen, in this view, where I'm writing my code, I can always click on the sprite and drag it back to anywhere I want it to start. So, here's my code. And let's click the green flag to see what it does. First, it points in 90 degrees, moves, points up, moves, points left, moves, points down, moves. And then maybe at the end, I want it to point in direction 90 degrees again. I'll go back to my control blocks to add a wait block. I'll go back to my motion blocks to add a point in direction block. And now I've got a complete script. I'll run it one more time. Change direction, move, change direction, move, change direction, move, change direction, move, and change direction. There we go. My cat's just walked in a square. Follow the coder's habit of writing a bit of code, testing it, and then debugging it. Debugging it means fixing any problems that come up. If I have a weird step in between that isn't working out, I can always separate my code to do a bit of debugging. Say my code wasn't quite doing what I wanted it to do. For instance, maybe I didn't want it to walk forward twice. I wanted it to walk forward and then point up. And that wasn't happening. Start to go through and try to debug. So I might look at my first couple of steps, remove part, and run just this first part. Forward, forward. Not what I wanted. So I know that my error is in here somewhere. Aha! I put point in direction 90 degrees twice. If I change that to 0, now I can run my code again. I'm going to click my cat, drag it back, run my code again. Excellent, I've solved the problem. Now I can add the rest of this code back and make sure it worked. Any code here that isn't attached isn't going to run because there's nothing here to tell the computer when to run this code. There's no input block here. So if you are writing code, make sure it's always attached to an input block, usually when green flag clicked, so that the computer knows that it's supposed to run your code. Let's do one more little test. I mentioned that some degrees are negative degrees. Negative numbers are numbers that are less than 0. Positive numbers are numbers that are bigger than 0. I can use negative numbers with my degrees, but I can also use it in my move block. In order to erase this code that I'm not going to use for this experiment, I can select it and drag it over to the blocks palette. When I let go, the code is erased. If that was an accident, I can undo my last step by clicking on Edit. It doesn't always work though. You'll notice this talks about restoring a sprite. I didn't want the ball back. So there often isn't an option to undo, but sometimes there is. Let's say I want my cat to walk forward and backward, but without changing direction, without ending up on his head. Right now, if I set my code to point to the right and move, then point to the left and move, you'll notice that he ends up walking back on his head. Maybe not ideal. So instead of changing direction, I'm going to tell the cat to always be facing 90 degrees, always be facing to the right. But first, he'll move 60 steps to the right, and then maybe I'll ask him to move negative 60 steps. A positive number will move us forward in the direction, and a negative number will move us backward in the direction. Let's see how this looks. Forward. I'm going to make the backward a little more dramatic. I'm going to make this number negative 120. I'll run my code one more time. Forward, backward. Excellent. So he didn't end up walking back on his head. There's a lot more blocks over here in the blocks palette than we got to today. But just simply using move, point in direction, and wait, you can already start creating a powerful script. Next time, we'll try some additional blocks. Also keep in mind, right now, I can't save my code because I'm not logged in. So if I wanted to save this bit of code, I would go to File, Save to your computer. I paused the video briefly and logged into my account, so you can see what that looks like. You'll notice I don't see the word Save Now at the moment, but if I drag some code away and drag it back, now you'll see the words there. So I'd want to make sure to click on them in order to save my latest code. If I click on my username and go to My Stuff, you'll be able to find all the code that you previously wrote. For instance, here's the program I just wrote. I can click on it to see the project. When I get to the project page, you'll notice a couple of things. One, it's telling me this project isn't shared. One thing about Scratch is that you can choose to share your projects or keep them just to yourself. If you share your projects, be aware that it's shared to the whole world. If you choose to share your code, you'll probably want to give it a title, maybe some instructions on how to use your program, and if somebody helped you, give them a thank you in the notes and credits. You'll also notice as you scroll down on your project page, there's talk about comments. Scratch users that are logged in can leave comments on other Scratch users' projects. If you prefer people not to leave comments on your projects, you can simply use the toggle switch to turn commenting off. If we use the blue See Inside button, that's when we can get back in to edit our code. So if we wanted to make a change, we would click on the project and then choose to see inside. If you wanted to get back to the project page, you could always click See Project Page. I hope you've had fun today. Thank you for joining me.